Yeah, I see. So we have people from all over, but especially a lot that are from NIAID and NIH. And it looks like a little bit of everywhere else. That is wonderful. All right, well, let's go ahead and begin. Let's see, I'm going to turn my wonderful camera on for a moment here. All right, hello, everybody. Welcome back for those who are joining us for now is the third time. So this is part of the, let's see here, the Python programming for biologists. My name is Burke Squires. I am with NIAID, the National Institutes of Allergy and Infectious Disease. I'm a computational biologist within the Bioinformatics and Computational Biosciences branch. And this branch is a group of computational biologists, bioinformatics software developers, and then project management and analyst professionals. And we provide what I call collaborative consulting with NIAID intramural researchers, and then with others occasionally as well. We have our portal, right, the bioinformatics at NIAID, or I'm sorry, bioinformatics.niaid.nih.gov. And here you can see the bioinformatics portal. And here we have the training resources. So we're in the process of moving much of this material to another page. And so much of what will be left here will be just the training resources. But under the training resources, you can see that we have a number of different categories. We do have an African Center of Excellence where we do training for a group or a school in Mali and a school in Uganda. But I would say what may be of particular interest to you all is that, right, the previous sessions and then all of the sessions that we're going to do here we're going to record them and then make the materials available, okay? And so you can go to bioinformatics.niaid.nih.gov. And then if you click on programming and Python programming, you can see that in our previous sessions, both the Jupyter Notebook recording and the materials are here. And the previous, right, concepts in programming, or introduction to programming, and video and materials are here. All right. And so with regards to the materials for today, as you may recall, let me get to the right spot here. If we go to the repository where I put the materials, at least initially, or where I work on them internally and then post them to the portal, this is the overall Python biologist repository. And here you will find all of the different sessions that have been we're either giving this time or have been given at one time, okay? And then I would say what is of most interest to you is the fact that if you go down to the bottom folder here under this zip archives, you can click on the 04 Python programming, and I will copy that link and then we can paste it here. And if you click on that, what that will allow you to do is to download the zip program or the zip file for just today's materials. Somebody's asking about a certificate, and we have not gone through approval, right, for these materials. Somebody had asked previously, we have not gone through, say, an institution to have them approved for content, right? So that means that you can't necessarily get like continuing medical education hours or anything. I would say if you're interested, you can email me and I can look through logs and make sure that you have attended one or more of the sessions, and then I can provide a one-off participation certificate if that would be helpful. Okay. So today, right, what we're looking at here is our let's see, the Python programming for biologists. As I mentioned, my name is Burke Squires, and I'm with the NIAID Bioinformatics and Computational Biosciences branch. And what we're doing here is we are teaching, right, a series of 8 different Python training seminars. You'll notice today that we are working with, we're going to be looking at the actual the Python programming language itself. In our previous session, we had talked about we had talked to those who had never done programming before or thought they had never done programming before. Now that we're going to cover the language itself, I would love to hear if you would paste in the chat if you have materials, I'm sorry, if you have programmed before, would you paste in the chat that you have, or what language or languages you have programmed in before? I would like to hear and see what kind of experience we have in our group today. All right. All right, so I see quite a bit of R. All right, some Java, a little bit of Python. All right. Well, I would say welcome. I hope that you all have something to learn today. There was a question about downloading materials. I previously posted an incorrect URL, and I'm sorry about that. So this is the correct URL that I've typed in the chat. So it's just github.com. It should not say localhost. I'm sorry, that was from my local machine. It should say github.com and then Burke Squires and then Python biologist. All right. All right, so it sounds like we have quite a bit of experience. And I would say, I hope that those who were here last week on Thursday have, of course, joined us so that you can learn the programming language in general. So I'm going to turn off my video, and that way we can focus on our wonderful materials. And so what we're going to do today is we're going to look at the Python programming language, and we're going to look at a number of other parts as well. So the first thing I want to cover is the installation. And so the understanding is that if you have joined us, if you joined us before, then you know that we're using the Anaconda distribution at Anaconda. Let's see, at anaconda.com. And this is a free download, but in the last few years, they have changed their licensing requirements. And so any company with more than 200 employees now requires licenses for their employees. And so I know that we have had some issue within NIAID, and we're working through, what level of licensing to work on. But I would say if you are not part of a company that's greater than 200 employees, then there's no issue. If you are at home, I find that I can install the software without an issue. But what you can also do is just go to python.org. And this is the official website for the Python programming language. And here you can see that there is an option to download Python. In this particular case, we would download Python 3.1.11.5. I would say if you're using almost any version of Python 3, then you will be fine for this training, right? So if you download this, you would have to install it on your system, and then you would use the pip installer. Let me see here if I believe the instructions. There is an alternative, or you can use the pip installer to install, say, the Jupyter software and any other packages that we have. All right. And so I would say if you're searching for it, you can look under Python and pip and install, and you should be able to find those instructions. All right, so we want to look at number 4 here, and why Python. And so this is a cute cartoon that is, it's actually a little out of date. There should be parentheses around the hello world here, but I'll give you a second to read that. So the reason I put this in here is because it's just really cute. It also shows you how quick and easy it is to actually, print something. The fact that you can import anti-gravity also takes you to, so this is what's called an Easter egg within the language itself. It takes you to that cartoon. And then how cute is that there is a cartoon, right, for the programming language. And so, yeah, William, we are working in, let's see, we're working in the 04_Python_programming. So if you downloaded the lessons today, let me see, I can, let me just close these out here and make sure that I'm doing the same thing that you all are doing. So I'm going to go to the zip archive and download the zip archive. So here, if I go to the link and I click on the download raw, it should, there we go, it should download for me. And then that archive, I'm going to unzip it or unarchive it. And then what I'm going to do is I'm going to go back to my Jupyter notebook. Okay. And so what you will recall, or what you may recall, is that once you install the Anaconda distribution, then the way that you would launch your Jupyter Lab or your Jupyter Notebook, we're going to be using the Jupyter Lab interface. So this is the Anaconda navigator that comes with the Anaconda distribution. And here I would click on launch. And then what that will do is that will take you to, it'll take you to this screen here, which is the Jupyter Lab screen. Because I have downloaded the materials, they're in my downloads folder. And let's see here. So we have the 04_Python_programming. And so this is what you should see. So I'm sorry if you all are getting an error. I would say if you try extracting the file and then refresh, thank you so much, William. It sounds like others have had a similar error, but have been able to get around it. One thing that you can also do is you don't have to have the materials for today, because we're really going to be going through and retyping in all of this stuff. And so if you're able, you could put a window on one side of your screen and then open up a new Jupyter notebook on the other side, and then you'll be able to type along with us, okay? And so so under, we've done the Anaconda distribution. You can just install from the language or from python.org, okay? As we will see, there is another Easter egg. As we will learn today, the import function within Python allows you to connect to a piece of code that is already on your computer. So if you install the Anaconda distribution, what you're doing is you are pulling down the Python programming language, the Jupyter Notebook software, the Pandas software, and a bunch of other Python packages, and you're installing them or copying them to your computer. Once that's done, then anytime you want to make use of one or more of those packages that's not explicitly part of, say, the core Python language, you have to use this import function. And so something like print, right, is part of the core Python language, and so I don't have to import anything to print, right, a message. This import this. So if you type import space this and then run it, this is yet another Easter egg. And I'll give you a few minutes to look through this. This is somebody's summary, I would say years ago, of how, so it's actually this gentleman, Tim Peters, of how he characterized, right, the Zen of Python, or the philosophy of Python. And so what you'll notice is that I'm highlighting on here that readability counts. And so over and over again today, I'm going to tell you and repeat that software code is read many more times than it is written. And so if you think about it, when you are writing code, you are reading, right, your code to yourself as you write it and then update it and then you debug it. If somebody else is reading your code or using your Jupyter notebook, as you all with my Jupyter notebook, then you are reading the code as well. And so the fact that Python has a big focus on readability, I think, is what makes it easy to teach, easy to learn, and makes it easy to use, right, most importantly, okay? Now, we saw this briefly in the concepts or the intro to programming. This is how you would print the word hello world in 4 different programming languages. And so what I want the take-home message, or what I hope the take-home message is here, is that what you can accomplish, right, in a single line of Python, you can accomplish in a single line of R as well, but there's a little bit extra that you need to add to it. But in other languages, it would take more code, right, to accomplish the same simple task. Now, programs written in C++ and Java, right, they certainly have their place, okay? And so, as I was saying in the previous session, I would not want to use a Microsoft Word or a Mac OS that is written in Python. It would be way too slow. But those written in C++ or Java, right, are much faster and more usable in that context. But I would say we are not writing an operating system, and we're not writing, right, a large application like Microsoft Word. Much of what we do is write small to medium programs, right, that do data analysis. And the idea of being able to iterate quickly, that means write a piece of code, test it, make sure that it works, and then write the next line of code and test it and make sure that it works, and keep on doing that and being able to do it quickly is where the real benefit of Python is for we as scientists, or we in a scientific environment. Okay. There are many reasons to learn Python. One of the main reasons is that it is an open source language, right? So there is no cost to obtain it. It is what's called a high level language. And what that means is that you can have a function like print that takes care of all the details in the background. So all I have to do is type that single word and whatever I want to print, and it will print, okay? Python is cross-platform. That means it's available for all major platforms and even non-major platforms. And so it's available for macOS, Linux, and Windows, but you can also get a version of Python, for instance, called MicroPython, that will run on microcontrollers such as the Arduino and Raspberry Pi. And so it is available on, I would say, almost all major platforms. Python is easy to install, whether you are going through python.org or using the Anaconda distribution. It's considered a safe language. It doesn't use functionality like pointers, such as the C-based languages do. And the advantage there is that sometimes pointers can point in the wrong direction, or point to nothing, which can give you memory leaks and then potentially open up a security issue. That is not something that's going to happen with Python. Python allows you to make your work more reproducible. And so the fact that it's easy to learn and speedy, right, and very capable means that you can focus on your science, right, or on your work, and it will allow you, right, to do that and to do it well. We've seen how, so those are ways that I would say many of the higher level languages are similar. There are ways that Python distinguishes itself. So one of the first that we've already talked about is the fact that there is an easy syntax, right? It's very readable. Python is a general purpose language, meaning that it differs from other languages, including R, in that it has broader functionality, okay? Python is considered batteries included because of the large standard library that it includes. And so the standard library is code that is installed with the Python language, but is technically separate from the core Python language. And it includes over 300 modules that allow you to do various tasks such as CSV importing, as we saw in our last training. Python is an object-oriented language, right? So it allows you to make use of that object or that programming paradigm. It's extensible. There are lots of add-on modules and libraries, and then it is widely supported, which includes, right, all of those people that are building those extensible libraries. But there is also a lot of content, right, and help available online. I haven't mentioned it before, but I would say please don't hesitate to interrupt if you have a question. If you'll type it in the chat, then I would be happy to take a look at it. What we see here is the scientific Python stack. Can you, yeah, you can take a screenshot of the packages, or this particular image, if you're, William, are you referring to the image you see now? Okay, so actually here, if you double click you can see that it's just called the Python Scientific Stack, and that is in the images folder that you have already downloaded. Okay. And this was something that I adapted from, I think Jake Vanderplas's, it was either Jake or, but I think it was Jake Vanderplas's work. And so here we see at the very lower level, right, kind of in the center of all of these circles, right, the Python language itself. And then what you'll see in this first layer around Python are the Jupyter Notebook, right, the software that we're using today, as well as the IPython kernel that actually is what powers this Python 3 IPY kernel up here in the right-hand corner. So we're already making use of the Python language, IPython, the interpreter, right? It's referred to as the Python interpreter on steroids, and the Jupyter Notebook or Jupyter Lab software. There is another core package called NumPy or numerical Python. This is something that you will, I would say, undoubtedly make extensive use of, but you may not actually know it, okay? Because when we're doing our data analysis, we're going to be using this pandas package extensively. And the pandas package is actually built upon the NumPy package. NumPy, in large part, is written in the C language. So it is an incredibly fast numerical analysis package that started out and is like almost exclusively, right, a Python related package, but they have recoded much of it in C to increase its speed. And then the other piece you see here is this Python, and this is another interpreter that allows you to potentially speed up your code just by using a different interpreter. In addition to, right, this first or this core layer, and then this outer layer, this first outer layer, we see in the third layer here, we have the pandas package that does data analysis that we've talked about. There is this long time plotting package called matplotlib, and we will make use of that in our data analysis class as well. There is a SciPy package that includes a lot of scientific algorithms. And then there is this SymPy that allows you to do symbolic math. And then if we take it one layer higher here, you have the stats model package. This is what allows Python to replicate much, if not, I'd say almost all, of what the R programming language, right, has. There's also this scikit-learn that does machine learning. There is this network X that works with networks, like biological networks, I would say. And then you have other things such as this PyMC that does Monte Carlo simulations, I believe, and scikit-image for image processing. And then the final part up here in the very top is this BioPython package. And that is something that we will take a look at in the bioinformatics session, okay? Now, there are many, many more, right, packages that are related to Python and to, right, the use in the scientific stack. I would say this is just a number of them, and it gives you some context of what is available, right, for use as scientists. Okay. William, when you talk about as PD, that means that what you're probably doing is you're importing when you're importing pandas, and as PD is just a way of assigning an abbreviation. And one reason for doing that, or I would say a main reason for doing that or enabling that function, is to make Python more readable. And especially if you have very long Python statements, if you can abbreviate something like matplotlib or pandas by 2 or 3 letters, then it allows you to keep particular Python statements on a single line, which improves the readability, right? So great question. All right, these are the links, right, to the various packages that we talked about above that you are more than welcome to, take a look at. And then the last part of this is why Python. There are a number of links down here, and these stem from a question I got years ago when I was teaching through the FAES on the NIH campus, and somebody was asking, what can you do with Python? And I thought that was an excellent question, especially for somebody who, had never programmed before. And so of these links, I would say this first one here, the Automate the Boring Stuff. This is a wonderful book that gives you a number of different options and examples for using Python to accomplish a number of tasks. It's written by this gentleman, Al Swigert, and the book is available for you to download or to use, here on the website. Okay, and then the code is also available for you to download and use. But if we look here, there is also a number, there's another website called Real Python, and this is a great website that has additional training materials. Those would be paid for if you're looking to extend your Python programming capability. But there's also a lot of examples here, and we can see just the categories, right, where Python can be used. So Python is very big in web development. You can use it, right, for game development, and scientific learning and machine learning and scientific computing. There also are ways to automate your workflow, whether it be through DevOps or software testing and database systems. But there are many, many, many things that you can do right with Python. I would say the more and more comfortable you become with it. Okay. Any questions on why Python? No? Oh, great question. So Robert is asking if you have to download the packages. And yes, you do have to download them. But I would say the advantage of using the Anaconda distribution is that I think almost everything in here is included. I know that at some point in the last few years, they have taken BioPython out, so that's something that has to be installed. But many of these are installed by default as part of the Anaconda distribution. Okay, and that's one of the advantages of using the Anaconda distribution. Let's see here. And then once you have, so this is just a link somebody was asking about downloading the materials. And so once you have downloaded the material to your computer, that you only have to do that one time, unless you are installing updates, right? So if there's an update to a package, that also has to be downloaded to your computer. But once you have downloaded it, then you would use the import module or the import function, right, to connect to it. And that you will have to do every time you want to use the package, okay?
Yep, that makes sense.
As far as the best IDE or integrated development environment, through this course, we are using the Jupyter Notebook or the Jupyter Lab interface as part of the Anaconda distribution. There is this Spider IDE, and we'll take a little bit of a look at that in just a second, as well as some other IDEs. And so actually that is a great lead-in, right, to our second notebook here and how to run the code in Python. All right. So no, it is not mandatory to have the Anaconda distribution installed. You just need to have the Python programming language installed. Okay. To run a Python program, you can do it in say 4 different ways. The first is just through the interpreter, right? So Python is an interpreted language, and that means that if I go into my terminal, okay, so I would say I'll just do this for demonstration purposes. So I wouldn't, if you want to play with this later, you can. If I type in Python, then that just shows that it's not being installed in the OS itself. It doesn't seem anymore. But if I go to my Anaconda folder, inside there is a binary or bin folder, and here I can type Python. And then what you'll notice is that the Python version that is installed, right, when I installed the Anaconda distribution was Python 11.4. And what you'll also notice is that when you are inside the Python interpreter, right, what this does is this takes Python code and it interprets it and then executes it on your computer. So this is how you get Python code to actually do something, right, on your computer. It would be helpful to be familiar when you are in the Python interpreter. You can tell because there are these 3 greater than signs. And so the 3 greater than signs means that I'm within the Python interpreter. And so here, if I type in the word print and hello world, and then I run that line by hitting return, you can see that it will print that message out to what's called standard out, okay? Those 3 greater than signs are something that you will come across every once in a while if you're searching for examples of Python code. So if somebody is answering a question about a Python programming concept or something, then often people will go in and they will just copy, right, the code that they've written. So they would copy this line here with the 3 greater than signs and then paste it in the help. And that will, and so then if you're going to use that code, you would just need to remove the 3 greater than signs. So I'm not sure, William, what's going on with the audio.
I can hear you.
Okay. So it doesn't sound like others are reporting it, so I'm sorry to hear about the trouble. Okay. So you can use the Python interpreter. That is one way to do it, to execute Python code. A second way to do it, or I would say the same way, but with a different interpreter, is through the IPython interpreter. And so that is the exact same as the regular Python interpreter. Normally, I don't just type in code in the Python interpreter. That's not how I type my Python code, unless I'm trying to test a very small line of code. But usually if people are going to run code explicitly through the Python interpreter, then what they will do is they will take a text editor, they will type in their command, into a text editor. So this print hello world, I would create a file called hello world.py. And then what I would do at my terminal is I would type in Python space hello world.py and hit return, and then it would produce the same effect as though I was in the Python interpreter. The advantage of doing this is that if I'm typing out a longer script and I don't have an IDE, then I can use just a text editor, right? Because a Python script is nothing more than a text file, right? So yes, so a Python script is it's not necessarily a notepad file, Mohammed. It's just a simple text file. Now the fact that Notepad worked with text files means that would suffice. But yeah, this statement here, right? All we see are letters, right, and then punctuation, and that can be perfectly well represented, right, in a text file. Okay. Throughout this training, and I would say today, we will also see how we use Jupyter notebooks, more specifically through the Jupyter Lab interface that you're seeing here. So I'm not going to go into detail right now with that. But then this word has come up a number of times already, or the abbreviation of IDE, or Integrated Development Environment. And this is another very popular way of writing Python code. I would say I use this when I'm writing longer code, or code that isn't necessarily a data analysis. So when I'm writing, say, Python packages or developing some algorithms, then I would use something like PyCharm. And what you'll see is that you can kind of see it in this screenshot here, that an integrated development environment is a text editor. So we have text here that's contextually colored. We have text here that is contextually colored. What that just means is that it is pure text, but the interpreter knows that it is Python code. And then that means that keywords are going to be colored differently, okay? And then the real advantage to something like PyCharm or Spider is that it allows you to view your files, similar to what we see here in the Jupyter Lab, but then it also shows you the values of variables as you are executing them, or as you are using the software. And so that makes debugging much more helpful. And so to answer your question, Keith, and I would say thank you, Emily, for already answering it. But yes, the PyCharm and Spider are very similar. If you're coming, say, from an RStudio world, these are basically Python versions of RStudio, right? So great question, and thank you for the answer. There is another, I would say, more recent competitor or contender here in the IDE race, and that is this Visual Studio Code. And I would say Microsoft, who develops this, has done a lot of work in the last few years. And I know that they have staff Python programmers that enhance Visual Studio Code to support Python. I think that's a great option. Not to be left out, there are other options. So somebody was asking a little bit earlier, I think, about Google Colaboratory. This is it's a custom implementation, I believe, of a Jupyter notebook. There is a website called Python Anywhere that brings up a web interface, or a web integrated development environment, or IDE, that you can use. And then there are other versions. So there's this version called Online Python, or the Python Fiddle. In addition to other versions such as this PyScript.net, or PyScript, which is you can just use as Python in a browser. And so there are many ways to run Python right, code. And so I would say you can pick and choose what you want. And then what was really, really nice and what we covered very briefly on Thursday is the fact that once you've written your code, right, whether it be in any of these different, areas or using any of these different means, I can take my code in large part, right, from my laptop here, and then place it on, say, a compute cluster that we have, at the NIH or at NIAID, and with some small tweaks, right, that code will run as well. Okay. And so great question. So Mohammed is asking do you have to upload your data to the cloud if you're using Python in the cloud? And I would say I almost definitely. And as you're tuning into, yes, there is there's confidentiality issues and personally identifiable information. And so I would say that's why you have institutes that have their own clusters. And then why Amazon Web Services, and I would say the other web services, have, in our case, they have like FedRAMP approved containers or means to use potentially PII, but then in a secured environment. But yes, that is something you have to be careful for. And then Keith is asking about a particular IDE for data analysis or programming needs. Yes, Keith, so that is a fantastic question. I find that Jupyter notebooks are phenomenal for data analysis. They are easy to test code in. It's easy to run through a bunch of different scenarios, and and then after I've run through all of those different scenarios, then I can go and I make a copy of a notebook, right? So I would go over here and I would go to the Jupyter Lab menu and I would say, save notebook as. I would save a copy of it, get rid of the cells that I don't need. And then what is really nice is that I can come back up to, right, my run button here, and I can say run all cells, or restart kernel and run all cells. And what that will allow me to do is to run through an entire data analysis, right, on a new data set. And all I have to do is change the first line of code where it's pointing to, right, a particular data file. Okay. If I am working on a larger Python specific package, right, not necessarily a data analysis package, I would say usually data analysis is within the notebook. If I'm doing, let's call it more hardcore Python, then in that case, I'm going to use, I have a license for PyCharm Professional that I will make use of. Okay, so great question. Now that's a personal preference. I've also tried out VS Code and like that a lot. I haven't used Spider as much. I think just because I had started off using PyCharm long ago. It also has a community edition, and so you can download the community edition of PyCharm and not Python, PyCharm. You can download the community edition, and it gives you many features that are incredibly helpful. And then there's a few that distinguish, say, the Pro, right, versus the community edition. But I would say as a starting point, the community edition is a fantastic tool to use. Okay. All right, so we've seen that we can run Python code, right, just through the interpreter, through a notebook, or through an integrated development environment. Let's look at the intro to Python programming and jump into the language. All right, so what I thought we would do here is that we would come up with a project. And now this project is, I would say after developing it, is tends to be more of an American-centric project, just because it's converting, say, from what we would understand are imperial units to metric units. But what's really neat here is that we can see, in my Jupyter notebook here, I'm defining my problem, So I want to write a Python program to do temperature conversion. And we're going to play with the Celsius to Fahrenheit here, but then you can very easily extend this, to support, say, Kelvin temperatures as well, okay? And that's something that, at the end of the day, or into the session today, that you will, I would say, be able to do, if that's something you're interested in. And then you can make use of the code that we will have written today. And to refresh your memory, if I have a Fahrenheit temperature that I want to convert to Celsius, I will subtract 32 degrees from the Fahrenheit temperature, and then I will multiply it by 5/9 to get my Celsius temperature. And then reciprocally, if I want to convert from a Celsius temperature to a Fahrenheit temperature, I'm going to multiply my Celsius temperature by 9/5 and then add 32 degrees, okay? And so if we're going to do this temperature conversion, we will want to, the first thing we're going to do is we're going to develop some pseudocode. And in our pseudocode, what steps would we need to take to convert, from one or more temperatures, to a different temperature scale? Anybody want to take a guess? And Mohammed, I'll get to that question in just a second. So thank you, Robert. So first, I would need to get some information on what temperature I'm going to start with, if we think of it in its simplest form, that means that we're going to start off with a particular temperature as we're doing our debugging, but ultimately, we would develop something like this because I either want to convert many temperatures that somebody has given me, or there's a file that I have that I'd like to convert those temperatures. And then Robert, you're right on. So if I have some information, I need to store it in my program. And hopefully when I store it in my program, I'm going to store it in a way that makes sense, or that's easy for me to remember. And we do that by using a variable. Okay, so we're going to read in our temperature. Then depending on on how we design our software, we may have to determine what scale the temperature was given to us in. And so if the temperature was given to us and it is if it's 35, we don't know whether that is Celsius or Fahrenheit, Either of those could be a legitimate temperature, okay? I'm going to use, one of these formulas here, say to convert, from Celsius to Fahrenheit, or Fahrenheit to Celsius. And then I'll want to do something, with that new temperature. Now, Mohammed was asking about why do I call it pseudo? And pseudo means similar to or like. And so when we say pseudocode, that means code that is not really programming or source code, but it is a lot like it. The idea is that we want to use English statements here to describe what we're doing. And then those statements are essentially the outline to our program. And so here in our pseudocode, right, we're outlining 4 different steps that we want our software, right, or our script to do. Okay. What I will hope you will see is that when you write out your pseudocode, you will find that many times that the Python code that corresponds to it is very, very similar. Okay. Now, what we're going to do is we're going to talk about all of the different, right, syntax or the different capabilities of Python today. And the first thing we're going to do is we're going to talk about data types. So data types, right, the different types of data that a programming language supports, right? As you would expect, Python supports, right, all of the available, I would say, common data types. So here we have an integer that I need to store, or a floating point number. And so if I come over to my cell here, and it seems like it's doing something a little weird, so I'm just going to restart my kernel and clear all output. Okay. That is unusual. And then let's refresh my page here. Right, there we go. All right, I'm going to close a few of these things that we don't need. Okay. And so here I'm just going to retype what we see. So here with x equals, that is really weird. Let me try closing my browser for a moment and then reopen it. And then what I'm going to do is I'm going to go to, it should be just local host. And then you have the 4 8s, or it should be in your, in the memory here. So I'm just reopening up, right, that page. And it is still acting very weird. Let's try a different browser. All right, well, this is good experience because here, if we go to our oh, you know what? Let's take a look. I wonder if I have, let me close this. Right, and then we're going to close this, and then we're going to close this. It may be that I need to relaunch it. Usually when you launch your Jupyter Notebook or your Jupyter Lab, it's gone back and forth in its implementation. Sometimes it will open up a terminal window and you can see the Python kernel working in the background, okay? And so let's just go back to our downloads, and here, and here, and see if it is behaving and running now. All right, that seems a little better. Well, that is really weird. Let's try one other thing here. I would say this may be another good example. If we need to just reinstall Anaconda, we can do that. So it used to be that you had a token that you could see in your terminal window. And so that doesn't look like it is working now. So let's see. So sorry about the trouble here. Let's open up a new Python terminal or Python notebook. There we go. And we'll see if we can just code along here. So here I'm going to go and I'm going to type in x equals 100. Okay. And then I can see here, and then if I run this code, so here I'm going to press the X, I can see that it has executed. That means that there is a 1 right in between the square brackets. Okay. And then if I type the y right, equals 32.0, this is a floating point number, then I can run that. And then once those are defined, I would say I can use a shortcut command with the %, and then the letters WHOS or whos. And that is it's a magic command. And what that does is that lets the Jupyter Lab or the Jupyter Notebook tell me, right, what information or what variables I have defined already. And so I can see that I have an X and a Y variable. If I simply type the X variable's name, just X, and then I run that, it will return, right, that value. And the same thing with the Y, it will return the Y value. Okay. And so William had a question about importing math. Math is something that you do need to import. That is a piece of the Python standard library. And so that means it's code that's installed with the Python language, but by default, it is not connected to your script. And so you do have to import, you would have to go import math, and then it would be connected, and then you could make use of it. Okay. So here, if we were to run that, and if I type math, period, and then a tab, I can see that all of the functions, right, built into that math package, right, are available to me now. Okay, good question. Let's see. Okay. In addition to right the X and the Y here, there are right other data types. So in this case, if I were to type my seek right equals A, T, C, and G. And then if I come back up and I run whos again, I can see now that there is a math module that's been connected. And I can see that now I have that the seek right is connected. And so somebody else, it seems like they were asking a question about errors. I would say what is wonderful nowadays is that if you get an error, so if I go to import math and I misspell it and I run it, then here down on the bottom it says module not found, right? No module named Matt. If I copy that and then just paste it into Google and run, odds are it is going to find right what that is. Now it may be, so here It may interpret that, right, as meaning matplotlib. And so that may be a little different, but I would say if we look at this example here, we'll be able to see that you have to import it or you have to install it. And so just I would say copy and pasting usually will get you right the majority of the way there. And Mohammed's asking about the %sign whos. That is something that is specific to the Python, the IPython kernel within the Jupyter notebook. And so I know that that's a lot to wrap your head around, but I would say if you're using the Jupyter notebook and the default Python kernel, these are magic commands that we can get to a little bit later. Okay, so if you look up Jupyter, Jupyter, right, that's the project here, and magic commands, you'll be able to find that information. I'm not sure if you can do it in VS Code. I think, if it works in VS Code, then what that may mean is that the VS Code is using the IPython interpreter, but I would have to take a look. That would be very interesting. Okay. And then most of the IDEs, they already display this information by default. And so that's why the IDEs are so helpful. Okay. All right, so we've seen that our data types, right, with the X of 100, the Y equals the floating point 32.0, sequence, which is ATG, and then we can also, right, define a new variable, in this case, NT or nucleotides. And then here, we can define a list, right, of the different nucleotides. And then what you'll notice here is that, right, when I define my string, it's single quote. It can also be double quote. So it doesn't make a difference whether you're using single quotes or double quotes, except that whatever you start with, you must end with. Okay, so you can't mix single and double quotes. And then here, this is where defining a list in Python. And this list it's also known as an array. And so here you have 4 elements in your array. And then if I type NT, right, and I run it, then it will just spit out, right, the contents, right, of that list. Now here we see in this, it's technically a block quote. What I've tried to do is we're going through, right, each of the components in the Python language, but there are lots of details that I think would bore you to death if we were to go through every one of them. So instead, what I've done is there is a project called the Learn X in Y minutes, and in this project, the specific version that we're looking at is going to be Learn X in Y minutes. This is one of the best overviews of all of the syntax and many examples of the Python language. And so this is something that I would say I refer to fairly often if I need to refresh on how to implement a particular a particular syntax. But what I've done is I've taken hopefully the relevant parts of that and then added them after the section where we cover that particular area. Okay. And so somebody is asking about so Keith is asking about the spaces between and after the operator here. They are not required, but as William is mentioning, what they do is they add or they enhance the readability. And so I can definitely, remove them all. But as you can imagine, if I have an entire line of code, in these instances where I do add some of the spacing, it makes it easier to read. And I think there is a particular focus, or I'm trying to think what the module is. It is not coming to mind. There are essentially grammar rules in Python. Let's see here if we can. Or the syntax rules, and there is a particular way to refer to them, and it is just not coming to mind. Let's see. Every year, they have PEP. So every year they have options to enhance the Python language, and this has happened from the very, very beginning. And so I'm trying to think if it is it PEP 8? So here under PEP 8, this is the style guide for Python code. And what is the advantage of PEP 8 is that if you find code, it should conform to these particular layouts here. And so, there is something, I would say, one of the most crucial aspects of Python, as we'll see today, is indentation. And so the way that Python knows, or the interpreter knows, what code is part of a function or part of a loop is that it is indented. And then once the code is not indented, that code is assumed not to be part of a particular, the previous function or a previous loop. And so indentation is very important. And so we can see here that according to this PEP 8, there are recommendations on doing both, naming variables, having space as we're talking about right around our operators, as well as indentation levels. Now, what is really nice is that the IPython kernel and in the Python kernel, when I'm writing code, it automatically, right, will do the proper indentation. And so if I take this code here and I come over and I, let's see, let me close this one. If I add this line of code, and what I'm going to do is I'm going to get rid of the proper indentation, okay? What you want to do in Python is, as your lines get longer and longer, you want to indent them to make them, or you want to break them on over multiple lines to make it easier to read. And so here, if I have these two variables and I have this third variable and I want to break that line, then when I hit return, you can see I don't have to guess, right, what the proper indentation is. The interpreter knows it, and so it will help me, right, to do what would be the preferred indentation. And so what I love about this is the fact that if I'm following these rules, then when I give code to somebody, or if they're following the rules and they give code to me, then I will be able to tell, right, or I will understand what's going on in the code, right, because of it following these rules. Okay. And so this PEP 8 is just a very early version, initially authored by Guido van Rosen, who is the original inventor of Python, right, on how to format your code and then how to make it look more readable. Okay. So great questions. So yeah, Keith, the automatic indentation, as far as I understand, I believe that is in other IDEs as well. Right, so great question. All right, so we're looking at data types. The next thing, and we've kind of hinted at it already, are these variables. And so variables are something that are, there's incredible flexibility, but I would say, reminds me almost of that Spider-Man quote with, with great flexibility comes great responsibility. And so as we're working through, remember our example here is that we want to do some temperature conversion. And so if I am storing a temperature, let's say that I'm storing a Fahrenheit temperature, I can use a variable such as temp, right, equals 32.0. Or I would say, but the problem here is that I know that I'm going to be working with at least two different temperatures, right? Both Fahrenheit and Celsius. And so just using this temp variable is ambiguous. So I don't know if that's storing the Fahrenheit version or if it's storing the Celsius version. And then as you can imagine, when you go to extend this script and you potentially add Kelvin, now there are three possibilities for what kind of temperature or what scale temperature that variable is storing. I could go and make things very, very, very explicit, right? So here, if I say temperature underscore Fahrenheit, then that really, right, does a great job of describing exactly what it's storing. But I would say the difficulty or a difficulty with this is that when you create variables this long, then it's going to, if your statement is very long, it may wrap over and make it harder to read. And so I would say that what I think is the happy medium here, right, is this this middle variable where we understand that variables in Python, they can only start with a letter, right? They cannot start with a number. And then you can have, right, any number of characters or numbers following, right, that initial letter. And so then here, if we use this f underscore temp or temp underscore f equals 32 degrees, then we have this, I would say, this good mix of something that's easily readable, it's easily typable, and pretty clear. Okay. And so Lothar is saying you still have to pay attention. So if you forget you are correct. So if I am typing a function name, or if I am creating a loop, and we can try this later where we purposely miss the colon, then you are very correct. Then you're right. It will not indent correctly. But then I would say that is one of those errors where it's relatively easy for the interpreter to find, and then it will tell us that there's a problem because we have left off the colon. But then you're right. Then you would have to, I would say, probably manually go back and perhaps work on the indentation. But if the indentation is not enough, right, what that will allow you, or what it'll do is it will also kick that back as an error. Okay. No, so there's no, there's nothing, I didn't do anything for the auto indentation. I did, use the comma here to distinguish, right? This is, it's actually, so we would say one parameter and a second parameter, and then I can, right, include a space. And if I go, and then if I hit return, it will auto indent. I would say, for the most part, I wouldn't get tied up into this and worry about it. It's something that in large part that the interpreter or the IDE will take care of it for you. And ultimately, I would say it's meant to be, right, helpful and make it easier for the code to read. Okay. All right, and so we've looked through our right, our variable here. So now we're going to have our F underscore temp, right, equals 32 degrees. And then of course, if I call F temp, then it will print out, right, what I'm looking for. By default, another readability issue, or the recommendation from PEP 8, is that if you have multiple words in your variable, then you separate them with an underscore, and then that right. So usually variables are lowercase with underscores. Okay. Let's see. Let's look at, so math, I would say, is it seems this is something that seems exactly like it should be. Here, if I'm trying to convert from this formula here into Python, right, then I would take a temperature. So if I have this Fahrenheit temperature already, what I would do is I would let's see, let's make it a C underscore temp, right, equals 32. And then if I am to multiply, right, so if I follow this formula here, I would take I'm sorry, we're going to make it 40 degrees. I think that's what the example is here. So 40 degrees. If I take, 40, let me create a new cell. So if I have 40 degrees and I multiply it times, let's say 9/5, and we'll put that in parentheses just to be clear. And then I add 32 degrees. Then if I run this cell, then what it will do is it will print out, right, the correct temperature, right, of 104 degrees Fahrenheit. Now this this 40-degree temperature, right, that is a number that we picked. And so we'll broaden that in a minute. Okay. The operators, I would say, if you've done other programming or worked in Excel, I think they're all basically the same. Right, the plus for addition, the dash for subtraction. You have the asterisk here for multiplication. What is that? The backslash for division. You have the percent sign for the modulus. You have two asterisks for exponentiation. And then if you want to do the floor division, then you put two backslashes together. Okay. And then I think this is, these are just some examples right here. And so I would say this is all right, pretty self-explanatory. Any questions at this point? No? Okay. Why don't we take a 5-minute break? And then let's be back at, what would that be? 2:35 Eastern. Okay, we'll be right back. What would happen if your sequence variable is longer? If your sequence variable is longer, Samuel, it should work fine. But I would say it may make it easy, a little bit more difficult to read as you go through the code, especially if you are having to refer to it, multiple times, right, in the same statement. So if you were to do that, so that would be like NT would equal, are you talking a list, or you could just say that it is, TT, right, GGG, or you could say that nucleotide, right, equals T, T, right, G, G, G. Okay. All right, we'll be right back. Okay, we're ready to go again. Let's see, so Neria, so yeah, you can, let's see, I'm not going to execute that if we go here. So yes, we could, this was right, the math that we were doing. And ultimately you're right in line with what we're thinking here is that we, you have, right, a particular temperature, right? So we're doing this, say, to test our code out or test our formula. We're going to pick one single temperature. We multiply it by the 9/5 and add 32, and we confirm, right, that it is the 104 degrees. But what we can also do is we can abstract, right, that temperature. And let's see, that seems to be behaving now. So we can abstract the temperature where we're going to write that our Celsius temperature equals 40 degrees. And then we can then take that Celsius temperature variable, right, multiply it by 9/5 and add 32. And then we get, right, as a validation, we get, right, 104 degrees. Now, this code right here is more abstract. And the only thing that we're not doing here is that we are, just a second, Keith. So the only thing that we're not doing is that we are not saving, right, this result. We're just printing it out. And so, Keith, you were asking if we hit the plus, right? And so then I think I just dragged it out. And then you can, right, create it, or you hit the plus, it'll create a new one, and then you just drag, right, wherever you want. Okay. But this is, I don't think I've ever used this functionality before, but I like it quite a bit. I like to see the, one thing over here, and then we can play over here if we need to. All right, so now that we have, I'm going to copy, right, this code here. Now that we have this particular code, what we can do, and I'm going to just get rid of this information here. I think that was probably from last time. And so we can take, right, I'm going to paste the code that we just created, right, the C temp equals 40 degrees, and then the C temp times 9/5 plus 32. Well, we want to save this, right? Ultimately, this is going to be our F temp equals, okay? And so here we're saving it, but we can take it even one step more abstractly. And then we can also learn, right, some new Python. What we want to do here is we want to define a new function. So I'm going to type in the DEF keyword, right, for define. And I'm going to say that I want to convert, right, C to F. So we'll say that these are my Celsius, right, to F. Then what I'm going to do is I'm going to have to input, right, some temperature. Now we know that that is the C temperature, okay? But because we're abstracting it, I don't necessarily have to, and I would say I may not, in fact, want to, right, repeat that variable, because the variable that is used, right, within this function will go away once the function is finished running. Okay, so and so then what is going to end up happening here is I'm defining a function, right? I'm giving it one parameter, a temperature, right? We, you can say that because you know that we're converting from Celsius to Fahrenheit, that temp, we can infer, right, that temperature is the Celsius version. And so the first thing we're going to do is actually we're going to get rid of this. Let me see. We're going to, we'll save it down here. It's a better way of doing it is saving it because we will reuse it. Okay. And then what you'll notice is that when we did hit enter after this colon, right, it does auto indent for us. And so, indentation is incredibly important in Python. And I think there are some people that find it frustrating, but I would say that the interpreter and then the IDEs, they go a very long way to assisting with it. And so it's not something that I find laborious, and I would say I actually find it incredibly helpful, because then that means that I don't have to type a bunch of parentheses or curly brackets around my functions or other syntax, and it makes it cleaner to read and faster to program, I would say. Okay. All right, so here, what we want to do is we want to take this previous line of code, and I'm just going to move it up so that I'm doing my conversion. Now I have temp here and I have C temp, so I need to remove the C underscore here. And then I'm going to take this temperature, do the conversion, save it into an F temp variable, or we could say, if we think of the C temp and the F temp maybe existing outside of our function, like in our normal script, then I'm going to call this, let's say, new temperature. Okay. And then if I come back to the line, and then I hit return, it's going to auto indent for me. And so at this point, I'm defining my function. I've done my conversion. What do I need to do next to make it useful?
I'd say return F temp, or sorry, new temp.
I know you're good. And so, yeah, hi, Katie. Good to have you. I'll answer that question in just a minute. So you're right. So at this point, my answer is still within the function, and so and that's not where I want it to be, right? This function allows me to do something and to to run it over and over again, but I really want to get it out of the function, so I'm going to return my new underscore temp. Okay. And at this point, I've finished defining my function. Now, Katie is asking a great question, and Katie, that is a fantastic question, because it is something that I would say I think I do all the time. I can leave C temp there, and we can do this, and I can say F temp and make this F temp. And then I can have this C temp, and then I can say that F underscore temp equals convert C temp. Okay. And so what we need to understand is that defining a function is really a two-step process. I define my function, and then I must call the function in order to make use of it. And so I would say, if that seems odd, or if there's any if that doesn't make sense, when you call the print function, you or I have not programmed in, right, what the print function is doing, but we call the print function all the time. Okay. This is similar. So we have to define the activity of a function, and then I have to call it and make use of it in order to actually, right, enhance or to call that function code. And so Katie's point about leaving the C temp here. So what you'll notice is that we have a C temp defined here. Okay. And then I am feeding that C temp into the function. So then it means that it would go in here and it would get used here. And then there's an F temp here and an F temp here. I would say just for clarity's sake, I would not do that. But ultimately, there is a concept called scope, and the outer scope here is different from the inner scope of the function. And so once you feed in your outer ctemp into the function, this is going to have a different memory space than this will have here. And so there shouldn't be any interference between the outer scope and the inner scope, but I would say, you know, it would be better to not do that, and then that way there's just no chance of any misinterpretation or anything funny happening in memory. And so then once we run this, right, then we will get out our 104, right, Fahrenheit temperature. Okay. And so I would say, as long as you were feeding something into the function, you should be fine. On occasion, if you refer to, like if I didn't do this, let's see, so if I don't do this and I were to say C temp, then I don't know, it might work in some instances. Let's see. So here it is technically working, but I wouldn't necessarily expect it to always work. So this is where you really want to have, you know, the temp, you want to give the function its own variable, and then and then I would say the inner and the outer scope will work correctly. Right? Does that answer the question, Katie?
Yes, I think the one question would be if you kept the function as it is now and then did new temp equals C underscore temp, it wouldn't know what C temp is, right? No matter what.
Yeah, so you're thinking, so yeah, at this point, you would be defining a new version of ctemp, but in a different scope. Because remember, within Python, right, that you don't have to do anything special to create a new variable. It would just run as is. And then if we did the percent whose, it would show you that there, you know, is a ctemp, there is an ftemp, but I would say once that has run, then memory clears it out, if I understand correctly.
Okay, cool.
Yeah, great question. Yeah, scope can be confusing. So cool. So Mohammed, we were just doing like a test or a learning exercise, but I would say I wouldn't necessarily do that outside. In this case, I think this is probably a good you know, example or a good habit to use, where we are technically sending in a Celsius temperature. But I would say, because we are naming the function, I think clearly, we could infer, right, pretty easily, if I were to come across this code, you know, in a bunch of other code, and I would say, oh, okay, I'm doing some conversion from C to F. I could write that all out, but I think that is also fairly, right, explanatory. Then the inference, or the pretty quick inference, would be that the ingoing temperature is Celsius, and then the outgoing temperature, or the new temperature, right, would be Fahrenheit. Okay. All right. And so we've already seen, right, the advantage here, right, is that we have now, I would say, fully abstracted, right, where now I have this function that I can use anywhere, right, in my notebook that I want. Yeah, so Robert, actually, input is very simple. I don't know that we're doing it in here, but it is just the word input. And so and then if I type in, or if I run that code, then you can see that it presents a small box, and I could put in there 40. And then when I hit enter, right, nothing happens because I didn't tell it to do anything. But if I run it again and I put ctemp at the end, then if I type in 40, then it will just spit out 40 as well. Okay. This is great. I would say I know that I have some Jupyter notebooks that need to access some internal NIAID tools. And in order to do that, you have to go in and type in, you know, a password and a username and a password. And so doing something like this, not this explicitly, because this is inputting, right, what I've inputted, or it's outputting what I've inputted. But there is an extension, I think, to the request module that allows you to type in the password, and it's not saved in the notebook and it's not displayed, but it's a great way to make use of that you know, input capability within a notebook. Okay. I'm sorry to hear that. So Olivia, if it's let's see, ctemp, I mean, equals input. Let's see. So there is it does, you know, show you that's it's very easy to miss box here. And then if I hit enter, then it should run. I'm not sure what to tell you besides if that's not working. My first thing I would say after the training is to try restarting the computer, and then, you know, open up the Jupyter notebook again, and then just try maybe, or now you could try just a blank notebook and see if that happens. Okay. Okay, so now we've seen, right, that we have worked out, right, a formula that's very easy in Python to convert to, I'm sorry, we worked out a formula, and we can see that it's very easy to convert that to a function. Okay, and then once we have done, let's say once we have done, you know, that function, let's take this code here. I'm going to copy this code that we just did, and then if I come down and I paste it, you'll notice that there's only one difference here, and so the only other thing that we're doing is in the instance where, and it's great that you all were asking about input, where the instances that when I grab the input, I am grabbing text, right, as opposed to a number. Okay. So if it's saying cell not executed due to a pending input, then I think you may have run input somewhere above in the notebook. What I would do is I would restart your kernel and maybe clear all outputs, and then try running that single line of code again, or that single cell, and see if it gives you the same error. Okay. All right, so here, what we've done is we have copy and pasted our code. Now this function, right, is very specific. It will only work for, right, the Celsius to Fahrenheit, but there's no reason that I can't just go in and then swap, right, the C and the F. Then because the temp variable, as we talked about, is within a particular scope, I can leave that alone. And then this time I'm going to change my code. So if we're going from Fahrenheit, I'm going to subtract 32, right? And then multiply by 5/9. And then get rid of this because I already moved it over there. Okay. And so now very quickly, once again, we have a Fahrenheit to Celsius conversion. Okay. All right, I'm sorry about the trouble, you all. I'm not sure why that isn't running. I would be happy to take a look at it after the training and see if we can figure out what the problem is. Okay. And so here what we've done is we've just taken, right, our function now, and we've made a few changes. Now, the advantage of, right, we don't have to make this a function, right? I can just make this, raw code and then leave it as is and then run it. The advantage of making something like this a function is that I can program it once and hopefully debug it once, and then I can call it over and over and over again. Okay. I could just put this code in a loop. We'll look at loops in a few minutes, and execute it, and that could be fine. But I would say we wouldn't have gotten to learn about functions. And the I would say the further advantage of functions is that if there is something ever wrong with your code, I only have to fix it right in one place, and then every other time I run it, right, it's already running that corrected code. Okay. It's very similar to the idea of the object-oriented program that we talked about that Python supports, and that when I wrap up things into functions or from the object-oriented perspective into a class, then it becomes these kind of self-contained modules, and I can enhance them as needed, and then make, corrections as needed, and then anywhere else that it's called, right, that's already taken care of. Okay. All right, with regards to functions, at this point, we've only added, right, a single parameter, but it's not limited to a single parameter. So here we can see I have multiple parameters. I can, if I'm explicitly labeling them, I can do them in any order. Otherwise, it's going to expect, say, in this case of add, it's going to expect that the first number is X and the second number is Y. Okay. But you can see that there is, additional capability here where we just aren't really covering it at this point. Okay. Now, the fact that we have taken the extent to develop this this function, that adds another capability for us to do some unit testing of our code. And so unit tests are something that allow you to verify that the code is doing what you expect it to do. You'll see here that we're importing a module called unit test. That means that it's part of the Python standard library. And so what this allows us to do is to, if we import unit test, then we can call this assert module. And in this assert module, what we're saying is that when I run this function, Celsius to Fahrenheit, and it's 32 degrees, I'm expecting, right, the correct answer to be 89.5 degrees. And then when I convert from Fahrenheit to Celsius, I'm expecting that 200 degrees Fahrenheit, right, is 100 degrees Celsius. Now, if you look up here, we can see that this really should be, in our first case, it should be 89.6. So if I run this code here, let's see, we didn't define this code up here, so I forgot to run this one. Let's run that. Okay, and then we can come back down and rerun this cell. And so let's make sure that I have my my math correct. Right, so if I have my temperature, I subtract 32 degrees from it and then multiply it by 5/9. Let's see what happens if I do 104, and then I convert from Fahrenheit to Celsius. So you're thinking brackets. Okay. Is that oh, how funny. So is that what is it, the PEMDAS thing where we need to subtract? So just a minute here, let's see. Very good call. All right. So if I properly pay attention to my order of operations, right, then it would work correctly, where I subtract first and then multiply. Thank you all. All right, so now if we go in and we run our test, so I could just sit here and be like, well, of course it's Princess, and I did that on purpose so that of course the assert would fail, and you would have a fantastic lesson about how wonderful unit testing is. Would you believe me? All right, let's see. So what that does is if I were to quickly, thank you, Lo, sorry. If I looked at the code that I had above, I would say it seemed like it, or if I were to do a cursory glance over it, I would say, well, yes, of course I'm subtracting and multiplying like I'm supposed to. But we can see here the advantage of using something like the unit testing. I would say there are different schools of philosophy. One of the test-driven development philosophy is that you don't write any code that you have not already written a test for. I think that's a wonderful goal to perhaps achieve or strive for. But I would say much of the code that I write is, I don't go and do 100% coverage. I almost never do 100% coverage. But in large part, we're not doing it right in production. But for certain things, especially functions that I'm anticipating working, the advantage here is that in 6 months, if I come in and I am updating my code, if I'm running these assertions and something is off, or I inadvertently make a change to my code, then it will fail these assertions, and that would be a good thing. And then not only that, but if I'm off just a little bit, then you'll also notice that it fails the assertion. So here, if it's 1/10 of a degree off, it still means that it's not correct. And so I would go in and look and make sure that my code is operating correctly. Okay. All right. Any questions on functions or anything else? Katie, that is a great question. How specific do you need to be? I don't know. It's a great question because it can be a very sticky answer. I would say often if it's that specific, so yeah, I would say if you're testing to multiple decimal places, I think what I would probably do is either find something that is like an input and an output that are easier to gauge, or what you could do is you could say something like 4 divided by 3, and then in that case, if you're expecting the kind of the ad infinitum or ad infinitum, you could perhaps get around it that way. But that's a difficult question, right? Because where we definitely take things for granted, that it is an exact answer. Very often when you get to that level, being a 10,000th or a millionth of a point off, the computer often is, and so we have to be careful. Great point. And so let's see. So Mohammed will cover loops in just a minute. Okay. Before we do that, I want to look. We've looked quickly at lists before when we were looking at data types. And so now, in this particular case, we can define a number of floating point numbers. Right beforehand, when we looked at a list, we saw that we can include characters as a list, and that just meant the single quote around the A, T, G, and C. In this case, we have a number of temperatures, and so because they are temperatures, then we're not going to put any quotes around them. If I define my F temps to be 0, I meant to be 32 degrees, 100, and that if I were to call F underscore temp of 0, then that would give me my first, nope, not temp, but temps. That would give me my first number. What is important to understand here is that Python is a 0-based language. And so that means that when Python starts counting indices, it will always start at 0. R is a 1-based language, and so the indices in R will start at 1, but in Python, they will start at 0. And so that means that I would understand that this position here is 0 index, 1, 2, and 3. Okay. And then once we have a list defined, we can do things such as calculating the length of our list. And so here we're using the built-in function length. Now, what you'll notice is that we are not importing math at this point, and so length is something that is built into the core language itself. All right. And then you can see down here that if I need to add to a list, I can append numbers. I can also pop numbers off. Okay. And then I can refer to them as by their indices. And then one thing that is wonderful about lists is that there is a shortcut. And so if I use this shortcut of -1 as the indices, then what it is going to do is it is going to, that's not going to do it, is it? Okay. And so if I define what is it? A list of strings. Let's see. Okay, and so we understand that a string is it's a list of characters from the Python perspective. And so here I've defined, NT to be A, T, C, and G. If I were to give it a 0, right, it would return A. But we can also count in reverse. And so if I use a -1, then it will automatically start at the thank you, Olidel. It'll automatically start at the end and then count backwards. And then if so I think temps. The same thing. Okay. And so Robert's asking, how would you search, right, for C in that list? Then what I would do is I would say if or right, for char in NT. And let's make sure we'll be very clear here that NT equals, right? All right. So a string, let's see, something I haven't mentioned before that's important to find, or important to understand, is that everything in Python is an object. And so even a number, right, is an object, or I'm sorry, even, yeah, a number and variables are objects. And that means that they have, additional properties and methods that go with them. And so the fact that we have this string, the string is in essence a list or an array in Python. And so Lothar, I would say, is entirely correct, where you can use the find function that's part of the string object. But I think the question was, this is one way to search for it, right? But ultimately, even better is, yeah, the find method. Thank you, Lothar. But what you'll notice here is that I'm using a for loop, and then I'm giving it as what's called an iterable or an iterable object, the function. And so then if we print it out, then we can see here, actually, I'm going to do and convert it to a list, and then we will get our little answer. Okay, but so Lothar is right. If I want to find it within the string, then I would do the find function, and then this is one way if it was a list. Okay, great question. All right, now there is a way to, it's reverse. So here it is. If we want to, if I take NT, and this is my list, and then if I do ::(-1 and call it, then what you will notice is that it will completely reverse that list. And so, this is something that I think is can be very helpful if we're talking about doing, reverse transcription on a sequence, and I need to completely reverse that sequence, then there is this shortcut that allows me to completely reverse the sequence. And so the understanding here is that the two colons, I would normally have a starting point of 0, and then I would have a point of, let's see, 4. So I would want to go 0, 1, 2, 3, and then 4. So the way that Python is going to work is that the first number, right, when I'm iterating over a list is going to be inclusive, right? And then the second number, the end number, is going to be exclusive. That means I start at 0 and go all the way up, but do not go to 4. And then this last number after the second colon is what is the step, or how often should I go? And usually the step is 1, which means I'm going for each integer, each value here. But if I leave these first two numbers off, it assumes start at the very beginning, go to the very end, and then do a complete reversal. And let's see. Gregory, great question. So let's see, I think we can do the same thing with, let's see, NTs equals, so yeah, and so it doesn't matter whether you're using a list or a string. You can use the same thing, because in Python, a string is in essence a list, right, of characters. Then you can use that same syntax. Okay. But I would say for the most part, if I'm working with nucleotide sequence or amino acid sequence or something, I'm going to leave it as a string and then work with it as a string. So Robert, I would say you're right. Great question. Will it work with tuples? I believe it will. So here, let's see. So a tuple is basically a list that cannot change, right? And so here I move, or I convert from a square bracket to a parenthesis, okay? And so then everything works the same, but if we go in and we try and do the conversion, then yes, it should work. But then what you'll also, I think it just reverses the tuple, and so I don't know. I wouldn't expect that you could change it, but yes, it does work with tuples as well. Good question. You're right. Yeah. So a tuple is something that cannot be changed, right? It's essentially a set, right? So a list is a subset that can be changed or appended to. A tuple is a subset that cannot be changed after it's defined. You can go in and you can redefine it, right, and add more to it, but then you're redefining it, right? You're not altering it. So I cannot append, right, or pop off of a tuple. Okay, good question. All right, loops we have seen a little bit. If we have our list of temps, okay, let's make sure that that is defined. So our f temps, and if we want to go in and we want to loop through, right, our I'm going to leave that code down here towards the bottom here. Actually, let me see, we can just cut and paste it. In order to write a Python loop, there are two different Python loops. There's a for loop and a while loop. The for loop means that before you enter into the loop, Python knows exactly how many times it's going to execute, okay? In a while loop, you do not know when you go in how many times you will iterate, and so you have to include some type of code that will test, right, whether you continue, and then if you don't continue, then it will stop. Otherwise, you create, right, the endless loop. But here, if I want to go and I want to search through, right, for a temp in f underscore temps. What I really like, or one of the many things I like about Python, is the fact that Python, because ftemps is a list and it's an object in Python, Python inherently understands that there is an easy way to loop through it or to iterate over it. And so I don't have to tell it, in other programming languages, you would have to say, define an intermediate variable I, and that should start at 0, and it should go to the length of the list. I don't have to do any of that. Python takes care of all of that. And so in this case, if I'm saying, right, for a temp in ftemps, then what I would want to do is I can print, right, the conversion. So if I can convert from F to C, then I'm going to add, right, the temp here, and I'm going to close my second parenthesis. And then what this will do, right, in 2 lines of code, I'm looping through, and then I am printing out, right, that converted temperature. Okay. And then in the example above here, and we'll get to this in a few minutes, if I use the keyword with, or with open, that is the kind of gentle way in Python of opening a file, and then if that file isn't there, it'll kind of gracefully fail, as opposed to crashing entirely. And so we would say open with. Here, like a little bit down below, we will define or create a temporary file with some temperatures in it. I save it as a placeholder, in this case, just F4 file. Okay. And then what I will do is, yet again, Python understands that that file is iterable, and it means loopable. And so I can automatically, it'll start at the beginning, and then at the end, it will automatically stop. And so, yeah, Mohammed, you're right. You don't need to know, or you don't need to close the file. I think let's double check it. I think you're right. I think the with incorporates that, but I've also found, so it's a great question, Mohammed. I found in the past that I think it's more when you go to print, or you go to like save a file, that you really, it's best to close the file that you're writing to, because it doesn't say appear in your file menu here with the Jupyter notebooks unless you close it. Okay, so great question. We can also, right, so we've seen how we can use lists, right, within loops. You can, if you just need to loop through a number of numbers, or you need to loop through a particular number of times, then you can use Python's built-in function called range. And what range will do is it will automatically create a temporary list up to, but not including the number. So remember, this is yet again where we have the 0-based language. And so for I in range of 4, it will print 0, 1, 2, and 3. Okay, but range is a great way if you need to loop through a million times. You can just put in there a million and it will loop through a million times. Okay. Olidel, I'm not sure where you're seeing the curly brackets. So range, if you're talking about range, range is a function, and the input is just some number, right, that you want to do it. Let's see. Oh, okay, I'm sorry. Let's see. I got it. Okay, thank you all. Great work. So in here, in this animal, in this code, the curly brackets, thank you all so much for my blind eyes here. The curly brackets are a placeholder for the format method. And so what is happening here is you're taking a string, and then right, everything in Python is an object, and so this string, even though you haven't even defined it as a string, but the fact that you're enclosing it in the single or double parenthesis, and then if you call the format method on it, what that will do is that will substitute, right, the animal variable for the curly brackets here before it prints. And so then what it'll do is it'll automatically, right, go through and print out the correct statement. So thank you all so much. So that the format method is one of the ways of say custom designing or creating, right, the custom strings like that. Okay. Speaking of string formatting, you all are so good. So actually we didn't do it above here, and so this is another example. Let me cut and paste this, and then let's look at it. And so this is, right, the same thing. So we would in theory be looping through, we'll create this file in a minute, but we would loop through the file. We're defining, right, we're grabbing the existing temperature from the file. We're doing the conversion and saving that as a new temperature. And then what you'll notice is that we're using, right, one set of parentheses here, another set of parentheses, and then in the format function, it will simply do a substitution. The first set of, curly brackets will get the temp, right, the contents of the temp variable, and the second set of curly brackets will get the contents of the new temperature. And then even more so is when we come down here and we look at this example. Let me see, I'm going to go down a little bit where we're working with files. And here, if you all are, if you're following along, what you can do is, this is another Jupyter or IPython specific command. Okay, I can go out and then create a simple text file that has these temperatures in it. But I would say if we make use of the Jupyter notebook here, I can call a magic, a Jupyter magic function. And where we saw before, right, the whos, let's see here, right, we saw a single parenthesis, no, I'm sorry, a single % sign, and then whos, right? When I do that, it shows me, right, what has been defined in my notebook. But the single % sign, all that does is it refers to the one line, right, that is typed on. When I use 2 percent signs in this Jupyter or IPython magic parlance, what this means is that we are redefining the entire cell. And so in this case, we're calling a magic command called write file. And then I have the name of the file that I want to create. And so this file or this command will go in, and as I run it, it will go in and then create a new file called C_temps. And then we can see that it has the entire contents of that cell. Okay. This is, of course, great for these temporary files, or these temporary files that we want to use. So here I'm going to define ctemps. I'm going to run and define the ftemps. Okay, and then we can see that each of those were created. Right, and so now we scroll up a little bit. We were talking about some of this string formatting. So now that we have the ftemps defined, I can open it. I'm going to loop through it as we saw before, So the for loop knows, quote unquote knows how many lines are in that file. I grab the data or that line. Now, what I'm also doing here is I'm converting it to a floating point number. Okay, if I don't do that, then it's going to give me an error because it's going to try and do a numerical conversion, on a on a 32, which are two characters, not the number 32. So to get around that, I'm going to put that float back. What that means, it's called casting a variable or converting a string variable into a floating point variable. And then once I've done that conversion, I'm ready to print it all out. What you will see here are all these little numbers. This allows me to add this first number here before the period, allows me to add some space. Okay, and then the number after the period, I'm telling Python how many significant digits I want to include. And then the F here just means that I'm dealing with a floating point number. And then you'll notice that I'm doing the same thing over here, but I included a little bit more space. So if I make this 6 again, then it will just eliminate a space or 2 here. And we can see that it moves over. And so this is this format method, especially with this floating point kind of annotation, is a nice way of formatting my output. Okay. So Katie, great point. So I would say the confusion is not surprising. Just I don't think I explained it well. And so in a Jupyter notebook, or what we're doing is we're learning the Python code here. And then in addition to the Python code, there are also Jupyter specific commands that we're making use of. Okay, and so if we look at the Jupyter, Jupyter magic, I think it's actually part of the IPython, interpreter. There are things called line magics, and that means that it allows you to, it is cool. Yeah, and I'm glad to see somebody else getting excited about it, because it's really, if you're going to be using this for, data analysis, these things can be just super helpful, right? So these line magics are things that change the specific Python statement or the specific statement in that cell. And then you have cell magics which go in and they repurpose the entire cell. And so this first example of cell magic is that if I am working in a Jupyter notebook, right, and I'm going to come over here and I'm creating this new, right, this new cell, this code cell, and I can tell because it has the brackets here. If I use 2% signs and the word bash, then what that means is that the interpreter is going to interpret any other lines in this entire cell to be pure bash code. And so I don't have to go outside of my notebook to execute a bash statement and then bring the data back in. I can do that, right, all within the Jupyter notebook. But this is nice because I can see all the bash code. And if I need to change the bash code, then I can change it and then just run it. And so it's an amazing functionality. And so you can repurpose it for different code, including, right, Perl, JavaScript, right, LaTeX. But then you can also, do the write file. And then on the line magic, trying to think which ones I use more often. What are the ones? Line magic, if I want to load a source code file into into the cell, I can do that. I can list, right, all of the different things. As far as I know, it doesn't work for R if you're using the R kernel. So this is something that extends back to the days when the Jupyter project began as the IPython project. And then they noticed that much of the code in the notebook was really becoming language agnostic. And so they separated the kernel, right, which is kind of the brain behind the notebook, from the notebook and the notebook running. And that's where they separated the IPython project from the Jupyter project. And then the Jupyter project can run different kernels, including an R kernel. But that means that functionality, the magic functionality, would be specific to the IPython kernel alone, right? Great question. Okay. Excuse me. All right, so we've seen, right, where we can work with right, strings. We can work with lists. With regards to files, we've already seen where we can do the open with. Right here, right, I'm going to open with the file and then just print it out. And so if I'm using the open with, now I would say, right, Python, of course, includes this functionality, but I would say often, as we will see in the data analysis, we may never, even use the open function, just because the Pandas data analysis package, it has its own function for opening, right? So it has its own way of opening files, and it's like a read CSV function. And in that case, it probably uses, right, the open function within it, but we don't see it. And then a lot is happening behind the scenes, where it's loading and processing the data ahead of time. And so it may be that you do data analysis for your entire life and you may never use that open function. Okay, but it's good to know, right, that it's there. if I need to, right, just go and right, work through or process, right, a particular document, okay? Now this is reading by default. What this really means is that it looks like something like this, where I am opening up the file, and then the single letter R, it means that I am opening it for reading. It means I cannot write to it. If I want to write to it, then I would have to include the comma and then the R in quotes. Sorry, the W in quotes. This would allow me to open and write to the file, okay? And then what this would also do is, if this file doesn't exist, then it would create the file, right, and enable me to write to it as well. So here we see, right, then I would use the f.write option to write information right into that file, okay? This is, I would say, an older way of working with files. So if you're searching through for some existing code, you may see this where you have the try and then the finally. This has all in essence been incorporated into the with, the with keyword. And so if you see this, I would say just plan on converting it to the with open command, okay? We've seen a little bit of, we've played a little bit with this, right? We have our two different functions that we've already defined, okay? And so now, if I take those two functions, right? So the two defined functions, and then in this particular case, if we define one more function, and I would say, I think if you, I would say for time's sake here, what we'll do is we're creating a larger script that based on, right, the temperature that we set at the very beginning of our script, we'll go through and we'll automatically do our conversion. Okay, so to begin with, we're going to define that the beginning temperatures are Celsius. Okay, and then what you'll notice is that we are defining a new function, a convert temp function. We're giving it a particular scale, but then what you'll also notice is this very interesting option here, where as part of our definition, right, one of the parameters of this function is a function in and of itself. Okay, and so you'll notice here that we go in, and if the temperature to begin with is Celsius, then we're going to tell it that we're starting with Celsius temperatures. But then what you'll notice is that I'm feeding into it, right, the name of one of our functions. And then what you'll notice is that this statement here, right, is using that function name and calling the correct function name when it executes to do that temperature conversion. Okay, and so it just seems it's a very powerful technique, and then the fact that everything in Python is a function, is an object, means that I have these types of capabilities. Okay? And so if I run it, I can see that I'm doing, right, these conversions from 0, 32, 100, and 212. Okay, but then if I come up and I change my temp from C to F, or from Celsius to Fahrenheit, and I run the script again, then what you'll notice is that it has gone in and it has grabbed the different temperatures, right? So it's no longer 4 temperatures, it's now 3, and then it's doing, right, the correct conversion, right, from Fahrenheit to Celsius. And so what you'll see here is that right, there is this powerful capability to to abstract or almost like include a meta function, right, where it's this conversion function, and then it will be filled in, right, during its execution. Okay, does that make sense, or is that confusing to people? Well, Alper, I would say I can see where it's confusing, right? And so, right, if we are to take this function here, right, where I want to convert, or let's see, if we have two different functions, one way of doing our conversion, right, is that we would say if our temperature is Celsius, then I would have to go in and I would duplicate, right, all of this code. So I'm going to just convert this. Let me see. If I want to be able to convert from Celsius to Fahrenheit, or Fahrenheit to Celsius, and I just want to have, right, this one letter up here that helps me know which one, I could go in and then copy and paste all of this code. And so if we're doing C, then what we're going to be doing is this is going to be right, my temps, or I could just simply say that my file is going to be C temps. And then here, I would go in and I would cut and paste this and comment this out. And then I would make this to be F, right, F temps. Right, because we want to make a use of our functions. I need to read in my file. And so I would go in and I would open up my my file of temperatures. And then what I would do is I would just tell it that this is going to be my, right, convert C to F, okay? And then down here, I would do the opposite and I would convert from F to C. And so each one of these, I'm reading in the appropriate, right? The file is going to change each time, whether it's Celsius temperatures or Fahrenheit temperatures. I'm going to loop through my file, right, and do my conversion, but that conversion, right, is going to use a different function each time, okay? And so I can, right, leave my code like this, but what you'll notice is all of this is duplicated, right, here and here, with two little changes. One is the file, and so all I have to do between these two is change this first letter, okay? And then the other thing that changes is which function I am referring to. Well, Python gives me the power to not only, right, change the letter here, but change the function that I'm referring to. Okay, and so then instead of referring to one specific function, just as we have a placeholder for this letter, I can have a placeholder for the function name, which is what this is. Okay, so I would say if it's not making sense, I would say that's not an important takeaway for the day. Okay. So William, yeah, you're right. So this is, we're just adding an additional right layer of functionality to make it more right abstract, or just be able to control the entire right capability using this single letter. Okay. And then with regard to the 8.2, as we saw above here, let's go back real quick. As we saw in this example, right, the spacing of the letters, the fact that we want the degrees Fahrenheit to line up, the equal signs to line up, and the degrees Celsius text to line up, that's where this 6 is gives us the spacing. Okay, so if I were to change each of these to 8, you would just notice that the spacing, it moves over and gives us a little bit more cushion here, more space in between. But that allows you to control how much space goes before the text, and then how many significant digits are after the text. Okay. All right, and then the last, and so let's see. This is also an example of right how we use the if, and then there is this interesting new word almost in Python called elif, and what that really means is it's a mash together of else if. And so this goes back to that idea of the Zen of Python, where I am putting in multiple choices here. And normally an if then else statement is nested. And if you keep nesting it, then it can be more difficult to read. And so what Python does is it mashes this elif or this else if together. And then you have your first if statement. You have an else if, but it's all say left aligned and easy to read. And then at the very end, there is this final else function if it doesn't meet any of the previous criteria. Okay. And then I think the last thing that we want to take a look at is there is a component here called dictionaries. And so these are key value pairs. And I'm just going to scroll down to the example here. So a dictionary is something where if you have hundreds or thousands or millions of key value pairs, and so I think a common example of something like this is if you have a student or a person's social security number or identification number, and you want to look up their name, you don't want to have to scroll through, say, a million people in a city. You want to be able to look up an individual based on a single identifier. And so the way that you do that in Python is you create a dictionary, right? It's key value pairs, where you have a single key, or the keys must be unique, but then you can have multiple values in there. Okay. And so if we think here of important temperatures, I have these curly brackets, and so that is an empty dictionary. I can add one important temperature at 32 degrees and say that that water freezes at this temperature if it's in the Fahrenheit scale. I can define another important temperature to be 0, and that water freezes here if it is the Celsius scale. And then I can do the same thing with both 212, right, and 100. And so as long as these keys are unique, right, they can have whatever value after them that we need or we want. And then if I call important names with square brackets, then it will retrieve the message that goes with it. Okay. I would say a neat example of this is in this case where we have 3 different for loops. What we're doing is we're combining them into a single trinucleotide, right? Or in what we're doing is we're making all possible trinucleotide iterations or combinations. And then we are using this count function, similar to what we talked to earlier with the find option. So here I want to go in and I want to count all of the trinucleotides of each trinucleotide in this particular DNA sequence. And then because we are saving this to our dictionary, I can then go through and I can call out a single trinucleotide, right, this AAA, and I can say that it is represented, right, 4 times in this sequence. And so what is nice about dictionaries is that this is something that is this idea of key value pair that is not represented in R, and it gives you some idea of how Python is it's more of a general purpose language, right, that I can add, say, the stats module to do all the statistics analysis, but then it also gives me, right, additional functionality as well. I'm going to skip the end of this, and I think that is it. And so I would say, there's this wonderful that Python learning Python 3 in Y minutes that you can take a look at, or the Real Python website has a lot of other functionality and tutorials. And so with that, I will say thank you very much. I hope that this has been useful. As always, if you have questions or comments or criticisms, I would be happy to hear them. If you will send me an email, that is my email address. I will, of course, put the training and the materials up on the NIH Bioinformatics repository. And then we will see you for the next training. And let's take a look at the Zoom. Let's go and look. And so in our next training, so on Thursday, we will look at the data analysis in Python, the first part of it, and then we'll finish with it next Tuesday. Okay. And then if you have other questions, let me know. Otherwise, we will see you on Thursday.